Download this code and get free GPT-4o from codegive.com, link in the description below. Sure. Let's dive into the basics of handling communications between applications. This is often referred to as inter-process communication, IPC. There are several methods to achieve this, and we will cover a few fundamental approaches: sockets, message queues, and HTTP requests. ####1. Sockets. Sockets are one of the most common methods of IPC. They allow applications to communicate over a network. Each socket is an endpoint for sending or receiving data. Example: TCP socket communication in Python. Here's a simple example of a server and a client using TCP sockets in Python. Server, server.py. Python. Import socket. Def start _server. Server_socket equals socket.socket, socket.af _inet, socket.sock _stream. Server_socket.bind, localhost, 12,345. Server_socket.listen, 1, #listen for incoming connections. Print, server is listening on port 12,345. While true. Client_socket, address equals server_socket.accept. Print, F connection from address has been established. Message equals hello from the server. Client_socket.send, message.encode, UTF-8. Client_socket.close. If ___name ___ equals ___main ___. Start _server. Client, client.py. Python. Import socket. Def start _client. Client_socket equals socket.socket, socket.af _inet, socket.sock _stream. Client_socket.connect, localhost, 12,345. Message equals client_socket.reqv, 1024, .decode, UTF-8. Print, F received from server, message. Client_socket.close. If ___name ___ equals ___main ___. Start _client. ###2. Message queues. Message queues allow applications to communicate asynchronously by sending messages to a queue that can be processed later. Example, using Python's queue module. Here's a simple producer-consumer example using Python's queue module. Python. Import threading. Import queue. Import time. #create a queue. Message_queue equals queue.queue. Def producer. For I in range, 5. Message equals F message I. Message_queue.put, message. Print, F produced, message. Time.sleep, 1, #simulate time taken to produce a message. Def consumer. For _in range, 5. Message equals message_queue.get. Print, F consumed, message. Message_queue.task_done. #create threads for producer and consumer. Producer_thread equals threading.thread, target equals producer. Consumer_thread equals threading.thread, target equals consumer. Producer_thread.start. Consumer_thread.start. #wait for the queue to be empty. Message_queue.join. Producer_thread.join. Consumer_thread.join. ###3. HTTP requests. HTTP is a common protocol for communication between applications, especially in web services. You can use libraries such as requests in Python to handle HTTP requests. Example, simple HTTP server and client. Server, server.py. Python. From http.server import base HTTP request handler, HTTP server. Class simple HTTP request handler, base HTTP request handler. Def do underscore get, self. Self.send underscore response, 200. Self.send underscore header, content type, text/plain. Self.end underscore headers. Self.ofile.write, be hello from the HTTP server. Def run, server underscore class equals HTTP server, handler underscore class equals simple HTTP request handler, port equals 8080. Server underscore address equals, port. HTTPD equals server underscore class, server underscore address, handler underscore class. Print, F starting HTTP server on port. HTTPD.serve underscore forever. If underscore underscore name underscore underscore equals underscore underscore main underscore underscore. Run. Client, client.py. Python. Import requests. Def fetch underscore data. Response equals requests.get, http://localhost 8080. Print, F received from server, response.text. If underscore underscore name underscore underscore equals underscore underscore main underscore underscore. Fetch underscore data. Hashtag summary. In this tutorial, we covered 3 basic methods for handling communications between applications, sockets, message queues, and HTTP requests. Each method has its own use cases and advantages. Sockets, great for real-time communication and applications that require a constant connection. Message queues, useful for decoupling applications and handling asynchronous processing. HTTP requests, ideal for web-based applications and services that need to communicate over the web. You can choose the method that best fits your application's architecture and requirements.